A very good morning, student. This is the lecture of object oriented programming using C++, and today we will see the last subpoint of the fourth unit, that is pointers and polymorphism in C++. So this unit has the 16 marks. This is the CO which is related to this unit, that is a use polymorphism in C++ program. Okay. In the last session we have studied the function overloading, operator overloading with unary operators and operator overloading with binary operators. In this today's session we will start the last subpoint of this unit, that is runtime polymorphism. So operator overloading and function overloading are the compile time polymorphism. In this session we will see the runtime polymorphism. So C++ supports the runtime polymorphism with the help of virtual functions. So in the next we will see what is meant by virtual function. So it is called late or dynamic binding because the appropriate function is selected dynamically at runtime. So what is the difference between runtime and compile time? Compile time means at the time of compilation or before the runtime. It is also called as the static or early binding. But runtime polymorphism is at the time of the execution of the program. So late or dynamic binding. So now we will see the virtual functions. Virtual means to appear like something while in reality it is something else. So virtual means what? Not real. A virtual function is a member function that is declared within a base class and redefined by a derived class. So virtual functions are declared in the base class, and again we can redefine this function in the derived class also. The virtual functions implements the one interface multiple methods psychology that underlines polymorphism. A virtual function is a function in a base class that is declared using the keyword virtual. So if we want to declare a virtual function, we need the virtual keyword. So now we will see the syntax to make a function virtual. Just preceded the virtual keyword before the function declaration in the base class. So see here the syntax of virtual function. Now class user defined name, here is the class name. Now private section we will declare data members or member function. In the public section we will see the virtual keyword, return type, function name, argument list. Now here we can declare virtual function by preceding virtual keyword before the function prototype. Now see here the example, virtual void show. Now show function is a virtual function. When virtual functions access normally, it behaves just like any other type of class member functions. However, virtual functions is used to support runtime polymorphism when it is accessed via a pointer. So if we want to call the virtual function, we need the object of the pointer. A base class pointer can be used to point to an object of any class derived from that base. When different objects are pointed to different versions of the virtual functions are executed. So for this we will see one program which after that we will clearly understand what is the virtual function. So see here the program, class base. Now base is the base class. Public, in the public section, virtual void display. Now this display function is a virtual function, means it is declared in the base class also, and again we will going to declare this function into the derived class also. So in the virtual void display function, here we are printing one sentence, that is this is base virtual function. Now here the declaration of base class is complete. Again here we are deriving new class, that is a class derived one, scope resolution, public base. Now here in the public section, again the void display function. Now this display function is a virtual. Here at the time of declaration in the base class we are using the virtual keyword, so no need to write again here virtual. So void display, here again we are displaying one statement, that is this is the derived one virtual function, and in the second derived function, that is the class derived to scope resolution public base, public void display. Here again we are going to display one sentence, that is this is a derived to virtual function. Now see here, this display function is declared in the three different classes. One is base class, which is preceded by the virtual keyword. Again these two in the derived classes. Now see the main class. Here base pointer P and B. Now B is the object of the class base and P is the pointer of the class base. Now derived one, D1 is the object of the derived 1 class, D2 is the object of the derived 2 class. Now here we are assigning the address of object B to the pointer. Now so P equal to address of B. Now if we want to call the function using the pointer operator, we need the arrow operator. So P arrow display. Now this function is going to call the member function which is declared into the base class base. Now P equal to address of derived class. Now here we are assigning address of this D1 object to the P. So P equal to address of D1. Now P arrow display. This function is going to call the function which is declared in the derived 1 class. And last, here the address of the D1 object is stored into the object P, pointer P. Now this P arrow display, this function is going to call the function which is declared in the derived 2 class. Now see here the output. First it will display the base class statement, that is this is base virtual function. Second is going to display the this is derived 1 virtual function, and last display function is used to display the statement which is written into the derived 2 class, that is this is the derived 2 virtual function. So now we will see the rules for virtual functions. The first rule, the virtual function must be member of the same class. Virtual functions are accessed by using object pointers like, see here. So P is the pointer and we are access the function using the pointer. Now they cannot be static member, must be non-static members. The prototype of the base class version of a virtual function and all the derived class versions must be identical. For this, see here, this prototype is identical in all these three display functions. That is, here no need of, here the argument list is not present. Again in these two functions there is no argument list. The all function has the void as the return type. So this is the fourth rule. The prototype of base class version of a virtual function and all the derived class versions must be identical. Next, we can have virtual destructor but do not virtual constructor. We cannot use a pointer to a derived class to access object of the base class, that is reverse is not true. If a virtual function is defined in the base class, it need not be necessary redefined in the derived class. So in the base class only we have defined the virtual void display, but in the derived 1 and derived 2 class we are only writing the void display. So there is no need to redefine the virtual function in the derived class also. A virtual function can be a friend of another class. Now these are the 8 rules for the virtual functions. Again next we will see the pure virtual function. Now most of the times the virtual function inside the base class is rarely used for performing any task. It only serves as a placeholder. Such a function are called do nothing functions, which are pure virtual function. Means when we declare one virtual function in the base class and it really do anything in the function, then it is known as the pure virtual function. A member function can also be made pure virtual by appending it with 0 after the closing parenthesis and before the semicolon. Function is a function in the base class with no body. This is a very important sentence. A pure virtual function is a function in the base class with no body. in the previous example, in case of the virtual void display function, in that program we are displaying one sentence, but in the pure virtual function, the base class with that function contain no body. Since no body, we have to add the notation equal to 0 for declaration of the pure virtual function in the base class. A pure virtual function in a virtual function that must be overridden in the derived class. We must implement all pure virtual functions in the derived class. Pure virtual function is also known as abstract function. So pure virtual function means what? It only declared into the base class with the virtual function, but there is no any body written into the base class. Instead, it is appended by the notation 0. We must implement all pure virtual function in the derived class. Pure virtual function is also known as an abstract function. A pure virtual function is a virtual function that has no definition with base class. See here the syntax: virtual, return type, function name, argument list equal to 0. So equal to 0 means pure virtual function. When a virtual function is made pure, any derived class must provide its own definition. If the derived class fails to override the pure virtual function, compile time error will occur. So see here, if we declare pure virtual function without any body in the base class, in the derived class we must write the body of the virtual function. A class containing such a pure virtual function is called an abstract class. We can define pure virtual function as the function which are only declared but not defined in the base class. So properties of the pure virtual functions: a pure virtual function has no implementation in the base class. Hence, a class with pure virtual function cannot be instantiated. A pure virtual member function can be invoked by its derived class. It is just placeholder for the derived class. The derived class is supposed to fill the empty function. So see here one program for the pure virtual function: the class number, protected integer value, public void set value integer I. Here we are assigning value of I to the variable value. Now virtual void show equal to 0. This is the pure virtual function, because here there is no any body of this function or no definition of this function. Now class hex type public number. Now this is the derived class, and in this we are going to write the body of the member function, that is a void show hex value. So here we are declaring the value. Again class decimal type void show value. Now class octal type, again here we are defining the function void show, that is of value. Now see here decimal type, hexadecimal type, octal type. We are creating the object of these all derived classes. Now d dot set value 20. Now here 20 is assigned to the value, and d dot show, which is used to display the value, decimal value. Now again for the hexadecimal and again for the octal. So 20, 14 and 24. This is the output of this function. So here dot show and dot show, d dot show, h dot show and o dot show. These all three are the pure virtual functions, because this show function is not defined in the base class. Instead it is defined in the all three derived classes. So in the program as shown, the base class number contain an integer called value, the function set value, and the pure virtual function show. The derived classes hex test, that is hexadecimal type, decimal type and octal type, inherit number and redefined show, so that it output the value of the value in each respective number base, that is hexadecimal, decimal or octal. Now this is the end of this fourth unit, that is the pointers and polymorphism in C++. In the next session, we will start our last unit of this object oriented programming using C++.